Welcome to Math, Minecraft Computers, episode I28, where we are going to build the 7-segment display for hexadecimal values on a 4-bit bus in Minecraft. We designed this last time in Logisim, and now it's time to build it in Minecraft. Okay, what I've done is I've moved behind the BCD display that we built with the 2 digits on the 8-bit bus, and I've extended, you can see, just the 4 bits on this side. I have labeled them A, B, C, and D, just like our Logisim, and it's time to build. Now, as you recall, the first thing that we do is we need all the AND gates that are 4 inputs along here that will select all 16 different inputs. But before we get there, we want to describe and talk about the Cartesian coordinate system. Now, the Cartesian coordinate system was invented by René Descartes as a mathematician, and he was in his bed one time watching a fly on the wall, and as it flew around and landed on spots, and he was looking up, he envisioned a way that he could record where the fly landed as points, and he thought about it being a grid of equal units to the right from the bottom left-hand corner, extending to the right with a positive value, so 0, 1, 2, 3, 4 in this direction. And then he thought, well, if he did the same thing, started with 0 and moved to him from the bottom left, in other words, it would be from the bottom left corner to the top left corner, and the same equal units, you would end up with an intersection of lines, which would be considered squares of equal distance, so those would be, say they were centimeters, cubic inches, whatever measurement he chose to use. And then as the fly landed, he could simply write where it was. That is, of course, what Minecraft uses as well. However, there's a third dimension, including for its 3D. So we have an X, a Y in this direction, and then a Z is generally the up and down. And so in Minecraft, it's the exact same thing, except the axes are just a little bit different. It has a Z in a different place. For our intents and purposes, as you realize, one of the things that we need to do is build a 4-input AND gate. So we're going to start that now. I'm going to put my first one right here. We need to make sure we leave room for a bridge. As you recall, we'll be bridging over something like this. So we want to make sure that we have room to come down like so. So our first input can start right here. Of course, remember that 4 input is going to skip 1, have one there, there, and then of course all the way across the front here, and then torches on all of those, and eventually a torch here somewhere. And then that is it. That is actually our input. This input can be anywhere we want for the time being. I'm just going to go ahead and put it right here in the center. And that's it. Okay, with our first gate built, we're going to need 16 of these, and of course we could build those, but who wants to do that? So instead, I think it makes sense to copy these instead of actually using them. Now, what I'm going to do is get rid of this for now, and we don't need these, we're just simply going to be copying this. So now, using that Cartesian coordinate system, we have to decide exactly where we are. Now we have to copy this one that we are, so we'll write it down first. And if you think about that, you see that our initial target here is 159, 15, 111. Now the way, of course, Minecraft works is, as you can see, it's got in the center of the screen, I have an axis, and as I move, that is always showing you the direction of the axis. So the coordinate away from us, in this case, is the Z coordinate, which is blue. That would actually normally be, if you think of that being from above, if we were looking down like this, that would be the Y coordinate on the Cartesian system, the one that runs up and down. And then the one that runs left and right, it would be the red one. And so you can see that it's, in this case, X is listed, and then the up and down coordinate is over here. Where I am is the Z coordinate. So the way Minecraft lists these is X, Z, Y, and there's a history for that. There was a work that was done to make Minecraft load chunks that it needs to display much faster by changing those coordinates. But what we want to do is copy those. So if we're starting here at 159.15 and we want to copy all the way to here and actually make sure we get this piece of wire as well, it's this block. So I'm going to put a piece of redstone down, and you can see that our eventual is 163.15, 117. Now we simply do some math to figure out the difference on this. And the y coordinates, or excuse me, the z coordinate, keep in mind, is this. This is as high as it gets. So a torch here gives us our coordinate. If we think about having that here, we would have another block sitting here, like this, with the torch on it, and that would give you your height. It's equal height. And that tells you that it is actually, that middle coordinate is 16. So that gives us the idea of what we need to copy. So we're copying from there. Thing is, I want 16 of these. So I could go by and do all of that, but it's very simple to figure out. If we simply subtract these, we find out that we have their width and distances. Okay, so we have, actually, if you just want to count them here, it's 1, 2, 3, 4, 5, 6, 7. And then we want to copy an 8, all right, because they're 8. So it's 8 in the y direction, and it's 1, 2, 3, 4, 5. So we have something that is 8 long and 5 and 2 tall. So if you think about where we're at and where we want it to be, our first one is going to be right here. So there's our target, 159.14, 119. I'm going to pull up the clone command, and we'll do it. So we start with the clone command. We put our source in, which is 159.15, 111. Make sure I get this right. Otherwise, I'll copy something in my world where I don't want. So there we go, 159, 111. It tells us where we want to end. We want to end at 163, 16, 117. So I'm going to check that real quick. We want to end here, which is actually 118. So we need to pull that back up. It's clone 159, 15, 111, 2, 163, 116, 118. That's always where we're going to copy. Now the question is where we want to put this. It happens to be right where we're pointed right now, which is 159, 14, but we actually want to go 15, okay? And 119. And there it is. Now, without moving, I'm simply going to look down here, and we're going to add 8 to that destination. Where it was the last one, keeping in mind we're always moving in this direction, that's the only coordinate that will change. So if we started here at 119, then we just add 8 to that. And of course, we get 127. So we just come this command back here, and we change only this number. This is the only place that we need to change it. It was 119, plus 8 is 127, because the source and the destination stay the same. So we just are going to replace this with 127, and we have yet another, and we just keep doing that. So there's 3 gates already. We were at 127, we add 8 to it. What do you get? 135, that's right, 135. There's another, and we just keep doing that. And we're going to do that for 16 times, so here we go. So we now have 16 gates. They are all lined up here. Now I'm going to actually put on the front of these what we are selecting, and these can be the signs. Remember, the way we're going to connect these is this is 0 and 1 and 2, and so forth. So before we actually get started on that, the first thing I'm going to do, the algorithm is going to work this way. We're going to go to the bus, and we're going to put on whatever number we want. This is 0. That is our first number according to Logisim. So we're going to go here, and we're going to put the output of, right here, 0. And then all we do is connect it to the wires that are on. So there's this one. We have to have a bridge. There's the next one. We have to bridge now to the next available wire that is on, which is going to be right here. And the only other thing we have to do is keep in mind the strength. You can see it's going to die right there. So we have to put our repeaters on here where we need them. And then we're going to do the last one here. And now you can see this AND gate comes on because that is what is on the bus. And so then we go on to the next one, which is 1. Keep in mind this is the least significant bit here, so we turn this on. This gate will now go off because we haven't selected it, but this one is on. So we put our sign here. And then we connect the wires that are, once again, red. So there's the first one. I should say on, I guess they're all red. And then of course here, we're going to have to add the repeaters. And we'll do that all the way across every time we do it. Whether the wire is lit or not, it doesn't matter here. 8 of them. Okay, that is that. And we bridge again. To there. Now you can see I already have to move a repeater. And there it is. So once again, I think the thing to always do is keep your repeaters lined up. So I should have made my connections first and then find out where I want the repeaters. All right, our last connection for this gate then is bridged here. And you can see that I actually need the repeater all the way back here. So this is our last time that I have to do this. So let's just do it again. And the repeaters then go here. In this case, we can't put the repeater there, so we're going to put it in front. It really doesn't matter. We will fix that later. And then we just have to check these in the top and make sure that we have connections all the way over. And we do, so we are set. So now we have 0 and 1 set up. Now if I were to do this slow and go through every gate with you, it would take forever. So this is where we go high speed, and you can follow along on the labels that I do. Last thing I need to do is get these repeaters in the right place. Just like that. All right, keep in mind, we go to the next gate, we put the value that gate is selecting, which in this case is going to be the 2, 0, 1, 2. We go over and put 2 on the us, like so, and then we connect up the wires to the next gate. Here we go. Okay, now with all the 16 gates in place, we now need to start establishing our vertical lanes that we go. So as you remember, 0 is going to be here. It'll have to cross over, so 1 comes out here, and then it will come up here, and so forth. So that's the next step, is to just establish these. So I'm going to extend these out. And one quick way to do that is get right on the dot that we need, which will be this square right here. If you bring up this and look in this direction, you can see over here on the left that we're moving the x coordinate. So we're going to stand right where we are, which is right here. We're going to say fill where we are at. And we want to go out about 20, or maybe 30, I think probably, let's see, 32, 40. 40 is probably safe, so that would be 204. And we stay in the same place this way. We stay in the same place this way. And then we do that with Minecraft. Redstone wire. And there it goes. And now I just need to move to all of these, stand right here in this position, and run that again. You see it's going to extend out there. So let me get that done. All right, now that we have that done, we can start bringing these wires up in their verticals. And we're just going to start that by skipping, connecting it in both directions. That one goes there. This one connects in this direction. And so forth. All right, so there's the F gate. Now if you look, we have all the vertical lanes established. That gives us an idea of where we're actually able to build our gates, because one of our connections that you see that we have into this first gate is the F comes all the way up, because it does use gate A, and so gate A is going to be somewhere in this area. So I just line gate A up with the 0, because it is used for it. Make sure that I come out past this. There's where the F would be coming into the gate. Just want to make sure that we have room. And we're going to put our OR gate right here. Now we just are going to connect them in. Remember that 0 does. 1 does not connect. 2 does. And so what we do is we bring this. It's the next connection, which is the 2. And we bring it this way. And we hook it into the 2, like so. We're not going to need this. And so we can get rid of it. The next connection is 3, so 3 comes in right here. And of course 3 is this one right here. See, there's the 2, there's the 3. Now we have to build bridges for this. No other way to do it. We've got to cross this wire. And we're connected into 3. And that's how we're going to do this. You just keep going. We obviously don't have a connection to 4. So we skip it. And this connection is 5. However, we put an 8 on, that activates all circuits. And then we're going to continue. That is it for Math Minecraft Computers episode I27, the first part of the Minecraft build of the hexadecimal display driver. Once again, this is not a build you want to do. We have better ways to do this, so don't worry about it. We will resume next time, starting with the segment C OR gate, which will connect the inputs required for the segment C into a single OR gate that will eventually go to the 7-segment display. Until then, keep on learning. Hope you're having a good time. Give me the likes, subscribe if you want more. This is Imroy, out.